So we are now into the last lecture on module number 10, which is on real-time data warehousing. So in this lecture I am going to talk about role of ODS. Now if you remember, while discussing architectural components of a data warehouse, we have already talked about ODS. So I'm not going to discuss ODS in detail again, but whatever features of ODS or characteristics of ODS are required, I have put that in the slides. So let me begin this discussion. So we already talked about this real-time data warehousing lineage. So operational data store, motivations for ODS and were similar to the modern real-time data warehousing. So basically this concept started with ODS way back in the early 90s, and implementation, as we know, we have seen of RTDW, which reflects a new generation of software, hardware and techniques. Say a word about ODS. So this we have already covered earlier, but just to set the ball rolling, so I'm putting these details again. So ODS, if you recall, is also called as Generation 1 data warehouse, and it's a separate system that sits between the source systems and the transactional systems, source transactional systems and the data warehouse. And hot extract is used for answering narrow range of urgent operational questions like was the order shipped or was the payment made. So it is mainly about operational queries, right? And ODS is particularly useful when ETL process of the main data warehouse delayed the availability of data, because ETL process would run only every day or every week or every month. So the data that you need is not there with you. And second case is that when while designing the data warehouse or the data marts for that matter, you have chosen a coarser granularity, right? So you had to aggregate data before you put it in the data warehouse or the data mart. But I need the most granular data. So the most granular data would be available in the ODS, right? So these are two situations when ODSs are particularly useful. So ODS plays a dual role. So serves as a source of data for data warehousing, and also it can be directly queried and supports lower latency reporting through creation of a distinct architectural construct and application separate from the data warehouse. So in some sense it is similar or analogous to the RTDC that we talked about, that is the caching, real-time data caching. But ODS has been there for a long time, and the concepts are more or less similar to RTDC, but there are certain other distinctions. So we can say that an ODS is half operational and half DSS, right? That is decision support system, and a place where data was integrated and fed to a downstream data warehouse. And it can again be treated as an extension of the DW ETL layer, because you need another kind of ETL to take the data from the ODS and put it in the data warehouse. And lately ODS has been absorbed by the data warehouse. So modern data warehouses now routinely extract data on a daily basis. So this daily is again relative. So if you're talking about real time, this could be every hour, right? And real time techniques allow the data warehouse to always be completely current, so that we have already seen. And data warehouses have become far more operational than in the past. So this is a typo. So in the past, and footprints of conventional data warehouses and ODS now overlap so completely that it is not fruitful to make a distinction between the kinds of systems. So you can say that a data warehouse has more or less absorbed the concept of ODS. And ODS can be classified based on the urgency and its position in the overall system. So you can see in terms of urgency there are 4 classes, and a data and an ODS can be internal or external. So class 1, so this is important. So if you look at class 1 ODS, so refresh cycle is real time. That is, there is no latency that is allowed for bringing in data from the source systems to the ODS, and the degree of transformations are very low, so we don't process this data too much, right? It is brought in as it is, more or less, from the source systems. Then we have class 2. So class 2 is from half hour to 1 hour store and forward mechanism. So you kind of group the data that is generated in the last half hour or 1 hour and then load it into the data warehouse. And degree of transformation is medium. And the third class is refresh cycle is daily, and this is the traditional batch processing, and I can do a lot of transformations if I need to. And class 4 and refresh cycle is ad hoc, and often involving pre-processed value-added information from a data warehouse, and degree of transformation is highest. And class 4 is kind of different from the other classes, because here the data warehouse, the data is enriched in the data warehouse and put in the ODS. So from a real-time database or real-time data warehousing perspective, so these two are suitable. So mostly, like, if you are interested only in real-time, then class 1, and if you are interested in near real-time, then we can also talk about class 2, right? So this is the context. So this again I have just explained in the form of table using and also annotating that with transformation details. And class 4, as I said, is updates into the ODS from the data warehouse and which are unscheduled. So let me remove this annotation. So data in the data warehouse is analyzed and periodically placed in the OS. Say, for example, customer profile data. So different customers have been buying products and they have a kind of a behavior, right? So this behavior is analyzed, and a profile of a customer is built in the data warehouse. So that profile could contain customer name and ID, customer volume, customer profitability, which could be high or low, customer frequency of activity, very frequent, very infrequent, and customer likes and dislikes. So this would be typically used by any portal, right, that is selling products. So this is the class 4, right? So it is just very different from the class 1, class 2, class 3, and these class 1, class 2, class 3 are different in terms of urgency. So real-time data warehousing advocates that instead of pulling operational data from OLTP systems in nightly batch jobs into an ODS, data should be collected from OLTP systems as and when events occur, and move them directly into the data warehouse. So this enables data warehouse to be updated instantaneously and removes the necessity of an ODS. So basically it is saying that you use the solutions for real-time data warehousing and to eliminate the need of an ODS. So based on all this discussion, so we can actually come to the conclusion that if an ODS exists, and that is type 1, and in some cases type 2, then it can contribute towards real-time data warehousing. And as we discussed earlier also while discussing ODS, that if it does not exist, then there is no point in building an ODS just because you want to build a conventional data warehouse or a real-time data warehouse. So with that, I conclude this particular module on real-time data warehousing. So we looked at the challenges posed by real-time data warehousing and the kind of solutions that have been proposed by different researchers in the area. and the next module, that would be the last module for the course, would be on the current trends in data warehousing. So there I'm going to talk about the world's largest data warehouse, give you details about that, and then I'll talk about big data analytics, and we'll talk about Hadoop and Hadoop solutions, Hadoop and MapReduce solutions for large-scale data processing, right? So that I'll start, that I'll record in very short time. Thank you.